Hey guys, these are some problems worked out from section 19 on grouping. So right off the bat, we have factoring questions all in section 19, 20, and 21. So we look at our factoring robot and we see at the very beginning, we have a factoring question for all three sections. The first thing we need to consider is the GCF. The next thing after the GCF is to look at how many terms we have. So if we have 2 terms, we'll be doing this. If we have 3 terms, we'll go down this path. If we have 4 terms, we'll go down this path. So section 19 has to do with grouping. So right off the bat, I want you to observe the number of terms we have in these problems. 4, 4, 4, 4, and 4. I believe that's it. Yeah. So hopefully you see or are marrying the ideas together that the first thing we always need to look for is the GCF. If there is a GCF, we'll factor it out. If there is no GCF, we'll ask how many terms we have. And in this section, we have 4 terms. So we'll go down this path. All right, let's look at grouping. So with grouping, first, you want to look at the GCF. So look at numbers and variables. If there is a coefficient of 1 anywhere in the problem, then numerically there cannot be a GCF. So there's a GCF, or there's a coefficient of 1 here and a 1 here. So number-wise, we don't have to worry about anything. Then we look at the variables. The only letter in the problem is an X, but this term doesn't have an X in it. So there's no GCF. We're moving past that. Then we count how many terms we have. Well, we have 4 terms. With 4 terms, we always have to consider grouping. Grouping is 2 GCF problems done back to back. So between these 2 terms and these 2 terms, this is group 1 and this is group 2. So basically you generate 2 groups and you factor out the GCF of each of those. So from the first 2 terms or the first group, we see that there's an X squared that's in common. So I can factor that out. And as we practiced in section 18, the first thing you do is you write your GCF. The next thing you do is you open parentheses. And then how what goes inside is you divide each term by the GCF. You divide the term by the GCF. So if we divide x cubed by x squared, we get x. If we divide x squared by x squared, we get positive 1. So we found the GCF of the first group. It's that. Now we look at the next 2 terms, taking in mind or taking care that whatever we put inside parentheses has to match this. So you have 2 options here. You can either factor out a 6 or a negative 6. How do you know which one to use? Well, let's factor out a 6 first and see what happens. So if I factor out a positive 6, I factor out the GCF, I open parentheses. How do I know what goes inside? Well, I divide the terms by the GCF. So negative 6x divided by 6 would be negative x. Negative 6 divided by 6 would be negative 1. Now, these 2 terms don't match. So that means this was the wrong choice. Instead of positive 6, let's see what happens if we factor out a negative 6 instead. Now, negative 6x divided by negative 6 would be positive x. Negative 6 divided by negative 6 would be positive 1. And now you'll notice that the x plus 1 and the x plus 1 match. So far, so good. Now, between this big term and this big term, we notice that there's another GCF, a GCF of x plus 1. So this is really GCF done once, the first time. And now we find the GCF of those 2 terms and factor that out. So again, as we've done in the past, we factor the GCF first. We open parentheses immediately after, and then we divide the terms by the GCF. So if you divide x squared times x plus 1 by x plus 1, you're going to be left over with x squared. Then you divide the term negative x times x plus 1 by x plus 1, and you're left over with negative 6. And that's it. This really is that simple. So grouping is basically GCF times 2. Or it's GCF done back to back. That's all grouping is. Again, to rehash, we use this whenever we have no GCF or we found the GCF, and then we count how many terms we have. We have 4 terms. So then we try grouping. Do another one. Number 3, we have a GCF, or we have a 1 coefficient, so number-wise, we don't have to worry about it. With x's, this term doesn't have an x, so there is no GCF. We can move past that. Now we group our terms, the first 2 and the last 2. Between the first 2 terms, or in the first group, we have an x squared in common. So I factor that out. I open parentheses immediately after. How do I know what goes inside? From section 18, we divide the terms by the GCF. So if we divide x cubed by x squared, we get x. If we divide 7x squared by x squared, we get 7. So x plus 7 goes there. Now between 25x and 175, we need to factor something out, keeping in mind that I want x plus 7 on the inside. Otherwise, this whole thing doesn't work. So actually, if we factor out a 25x divided by 25 will just be x. And then 175 divided by 25, you can use your calculator to confirm, but it is indeed 7. So this is the first GCF, or the first stage of GCF. And now we have to find the GCF again. Because we have to find the GCF again, hopefully you understand why these 2 things have to match. Because if they don't, how do you engage in the second greatest common factorization? You can't factor anything out. So at this stage, if we factor out the GCF, which is x plus 7, I open parentheses immediately after. And now what's left over if we divide x squared times x plus 7 by the GCF x plus 7, well, we're left with x squared. So x squared goes there. Next, we divide 25 times x plus 7 by x plus 7. That gives me 25. So plus 25 goes there. And that's the end of the problem, so close parentheses. This is my second stage, GCF number 2. Now, I didn't mention this at the end of the first problem, but how could you check to see if what you've done is correct? So pause the video here. I want you to think about it and see if you can actually genuinely figure out for yourself if all of this is done correctly. So pause the video, think about it, and then come back. Hopefully you've had a chance to think about it, and also hopefully you came up with the idea, if you foil this out, and you've done it correctly, you'll go back to that. This will go back to that. Because again, 2 times 3 equals 6, this process is called multiplication. Taking 6 and breaking it apart into what things multiplied to give it 6 is called factorization. So if we take this whole thing, this is kind of like our 6, we can break it apart into 2 times 3. And if we were to reverse the process, if we multiplied the 2 and the 3, we should be able to generate 6. Not that 6, but this whole thing represents 6 in our analogy. And the other questions are more or less the same. Yeah, they really are the same. I guess I'll do one more, number 2, perhaps, just because the coefficient is 2. So if we look here, we cannot use the argument that, oh, one of the coefficients was 1, so there's no GCF to be factored out. If we look at 2, negative 750 and negative 175, the smallest number in this list is 2. So we write down factors of 2, which are 1 and 2. The only GCF could either be 1 or 2. It can't be any other number. So for instance, I can't find factors of 25 because the factors of 25 would be greater than 2 and 7 potentially. So then it's not a common factor. Not all the terms can pull out a larger number. So from the number point of view, factors of 2 are really just 2. So does 2 go into 50? Yes, but does 2 go into 7 or 175? No. Those are odd numbers, 2 is an even number. I can't really do anything with this. Which means number-wise, there is no GCF to be had. And then we look at variables. Well, all 3 terms have an X, but this term doesn't have an X. So there's no GCF to the entire problem, which again means if there's no GCF, I ask how many terms we have. Well, we have 4 terms, so then we consider grouping. Coming back here. First group, second group. From the first two terms, I can factor out an x squared, open parentheses, and now how do we know what goes inside? We divide the terms by the GCF. So if we divide 2x squared by x, I'm sorry, 2x cubed divided by x squared, we get 2x. Negative 7x squared divided by x squared gives us negative 7. Now we look at the next two terms, 50x minus 175. We can factor out a 25. So plus 25. And if we divide 50x by 25, we get 2x. If we divide negative 175 by 25, we get negative 7. So this is our first GCF or GCF stage 1. And now we have to find the GCF one more time to be done with grouping. So between this big term and this big term, we see that there's a GCF of 2x minus 7. So we can factor that out. Now, if we factor that out, we divide the first term by the GCF 2x minus 7, and we're going to be left with x squared as our quotient. Then we divide 25 times 2x minus 7 by 2x minus 7, and we'll be left with 25 as our quotient. That's our answer. We have successfully done GCF twice, or we've done the greatest common factor twice. Hopefully that makes sense. Question 4 and question 5 are exactly like the other 3 that I've done. So stop here with section 19. We'll see you again in section 20's video.